Hi, my name is Angela, and today I'm going to be presenting our key activity project. For this key activity, we decided to work on a hydro garden or a happy garden, which is essentially a small and accessible garden that everybody can have at home, that the plants get watered by a self-watering system, and we also check the humidity with a humidity sensor to prevent dryness. So with the actual code, we start off by stating a servo motor, which we are using as our water pump. We couldn't get access to a water pump, so we decided to just use the servo motor to represent the tap opening and closing. After that, we do the same, but with a water level sensor that's gonna detect our water and how much water we have in our container, so that the servo knows when to open and when to close, so that the plants can get watered. And then we do again the same thing, but with a humidity sensor. This one works for the soil of the plant so that we can know how dry or how wet the soil is. So that gives us a warning to do something about it. Then this is just for the serial monitor where we have our servo and our LED. After that, we start actually programming, but we begin with the water level sensor. So we have that stated here, and we mapped it as well from 0 to 100, so it would be easier for us to convert the values and print them. And so after we map it, we print it. And then the way it works is pretty much as long as we have a value of the water level between 25 and 100, the servo is going to open. Once it opens, it's going to let the water out and water the plants. And then once we have a level under 25, it's gonna automatically close. You can also hand close it if you would like to close it earlier, but that is how it is programmed here. And then after that, we did the same exact thing, but with a humidity sensor. We originally had a temperature sensor on Tinkercad because there wasn't any humidity sensors on the Tinkercad to create the fake Arduino and start coding. However, once we actually worked on the physical Arduino, we could get a humidity sensor and programmed it so it would work with that. We start off with mapping it as well. For this one, though, we did values from 0 to 50. But again, that would make it easier for us to print it and convert the values. We then print it onto the serial monitor, and then how this one works. As long as you have a value from 25 to 50, that means that your plant is too dry. So the higher the value, the drier it is. Once that sensor detects it, it's gonna have the buzzer that we have in the Arduino. It's gonna start making noise, and then a red LED is gonna light up. However, once your humidity sensor detects a value smaller than 25, so for example, 24 or 20, the buzzer and the LED are gonna automatically turn off. You're not gonna hear anything, you're not gonna see anything. And this is because the smaller the value, the wetter it is. We have this set to these specific values because of the plants we personally worked with. However, these can be changed. We worked with succulents, so these are extremely dry plants. So we needed a different range of values than sometimes other plants could need. And then something that we could have done to better our project, or something that our project could be missing, is maybe more sensors, like a pH sensor for the plants or a temperature sensor as well, like we originally had on the Tinkercad. But this time for the surrounding environment, just to know, because different plants need to grow at different temperatures. So if a plant isn't in the correct temperature, it won't grow the same as if it is. So with that, you could control it. We could also use a sprinkling system, which in the original drawing of the prototype, we had set up as 4 different sprinklers, and that would provide all of the plants with water. However, that just wasn't possible with our time frame, so we decided to do it this way. But overall, we had a really good project, and I hope you liked it. Thank you.